Hello, how you doing? Have you heard the terms shallow versus deep in the context of neural networks? And you're not quite sure you know exactly what this is. Well, if so, then watch on with me for the next few minutes and I will quickly get you up to speed. Okay, let's get started. Okay, so let's compare 6 different aspects of shallow versus deep neural networks, including architecture, complexity, feature learning, training, data, and typical use cases. So first, how do shallow and deep networks differ in architecture? Well, shallow networks typically consist of 1 or 2 hidden layers, making them simpler in architecture. Deep neural networks, on the other hand, have multiple hidden layers, allowing them to model more complex patterns. So how does complexity differ between shallow versus deep networks? Well, shallow networks are better suited for simpler problems with less complex patterns. Deep networks excel at complex problems that require learning intricate patterns and relationships like those in images or text. Next, how are they different with regard to feature learning? Well, shallow networks learn features directly from the input. Alternatively, deep networks are better able to learn hierarchies of features, starting with low-level features in early layers and building to more complex high-level features in deeper layers. So moving to the fourth aspect, what are the training differences between shallow and deep networks? Shallow networks are generally easier and faster to train. Deep networks, on the other hand, generally require more computational resources and can be more challenging to train. So what type of data generally fits best for shallow and deep neural networks? Well, shallow networks are usually more effective for smaller data sets. Alternatively, deep neural networks usually do better with large amounts of data. So what are the typical use cases for both shallow and deep neural networks? An example of where shallow networks excel is in a predictive model that is based on just a few features. A good example of this is a surf forecast prediction model based on a few features such as wind and wave heights. Alternatively, deep networks are better suited in use cases with lots of data, such as image recognition and natural language processing. So why is understanding shallow versus deep networks important for neural network design? Well, understanding the differences between shallow and deep networks helps in selecting the right architecture for a given task, ensuring optimal performance. This choice between shallow and deep networks depends on the complexity of the problem and the available resources. As we all see in the news, the trend in AI has been toward deeper networks as computational power and data availability have increased, enabling big breakthroughs in various fields. However, it should be noted that shallow networks still have their place in simpler applications. Okay, so let me know what you think of shallow versus deep neural networks. Feel free to share your thoughts in the comments below. I want to hear what you think about this topic. Okay, thanks for watching. This video, along with all the other videos in this playlist, are listed in the YouTube description. I invite you to watch other videos on my channel. If you like the way I'm sharing this content, please consider subscribing. When you subscribe, this really helps my channel grow. One last thing, we all love technology and we're all excited about all the innovation with the cloud and machine learning and AI. But don't forget to carve out some time to live in the real world. Go outside, go swimming, go hiking, go climbing, go surfing, but get out and move your body. And if you do, let me know in the comments. I want to hear about this as well. And with that, have a great day. Thanks.